This video is about the effect of the atmosphere on an orbiting object. Let's picture planet Earth and a satellite that is orbiting Earth in a low orbit. Such satellites are at an altitude of 2000 kilometers or less above the surface of Earth. The atmosphere around Earth is made up of different gas particles. This atmosphere does not just abruptly end at a given altitude, but its density gradually decreases as we move away from Earth. An important consequence is that for satellites in low orbits, the drag force due to the atmosphere still has significant effects over time. Let's discuss these effects. As the satellite collides with the gas particles in the atmosphere, energy is transferred from the satellite to these particles, and the atmosphere heats up. Of course, this also means that the total energy of the satellite decreases. Recall from an earlier video that the total energy of an orbiting satellite is equal to negative g times uppercase m times lowercase m divided by 2r, where g is the gravitational constant, uppercase m is the mass of Earth, lowercase m is the mass of the satellite, and r is the orbital radius, so the distance between the center of Earth and the satellite. Now, as total energy is a negative value, when this total energy decreases, in other words, when it becomes a smaller negative value, r, the orbital radius, decreases. Of course, g, uppercase m, and lowercase m do not change. This decrease in radius has an interesting effect on the orbital speed of the satellite. We learned earlier that orbital speed is equal to g times uppercase m divided by r under the square root. This formula shows us that when r decreases, orbital speed actually increases. This of course means that the kinetic energy of the satellite also increases. We also learned in an earlier video that the total energy of an orbiting satellite is the sum of its gravitational potential energy and its kinetic energy. In addition, gravitational potential energy is negative while kinetic energy is positive, and since the magnitude of the gravitational potential energy is twice the magnitude of the kinetic energy, we can write that negative EP is equal to 2 times EK. We are putting the negative sign in front of the potential energy to make both sides of our equation positive. If we now denote the total energy lost by the satellite as EL, we get to the final key point in this video, which is that the change in the gravitational potential energy of the satellite is negative 2EL, while the change in the kinetic energy of the satellite is positive EL or simply EL. In other words, when the total energy of a satellite decreases due to the drag force exerted by the atmosphere on the satellite, the kinetic energy of the satellite increases, and the gravitational potential energy of the satellite decreases by twice as much as the increase in the kinetic energy. So this wraps up our learning about the effect of the atmosphere on an orbiting object.